Hey guys, Mr. Barnes here again, bringing another math video. In this video, I'm going to give you I did an absolute value video last night and I thought I did a crap job with it. So I thought I might do this little supplementary video to help you with that. So absolute value is one of those things that sometimes causes people some headaches. So if we have an absolute value function, let's call it 2x plus 4. So this is the absolute value of a linear function. So if we want to write this as a piecewise function, we have to really think about what this graph looks like. So if I look at this guy, it has an x-intercept, well it has a y-intercept of 4, and it has an x-intercept, so that's the y-intercept right there. And the x-intercept is just 2x plus 4 is equal to 0. So x is equal to -2. So there's the x-intercept, there's the y-intercept. So if I just do a quick sketch of this guy. So here's my -2 right there. Here's my plus 4. So that's one piece of my absolute value function. The other part looks like this. So they always look like these, linear absolute value functions. So this graph consists of two lines. This line right here and this line right here. So this line right here is called 2x plus 4. So that is literally just the positive of what we have here. This guy right here is, I'll call it the opposite of this line. So this line right here, well, you know that it has a negative slope because it's going down this way, as opposed to this one that's going up as x increases. So it's actually the opposite. It's negative 2x plus 4. So this guy can be written as two pieces. So as you can see, it's clearly divided into two pieces. So -2 is sort of my boundary point where it's sort of the division of that occurs. So as long as x is greater than -2, I have this guy. As long as x is less than -2, I have this guy. So there's my piecewise function I can write. So I can go 2x plus 4 is equal to x plus 2, x plus 4, 2x plus 4, as long as x is greater than or equal to -2. And then -2x plus 4 as long as x is less than -2. So I have an equal to part here. It doesn't matter which part it goes to. I usually put it in the top part. But there it is. There is my absolute value written as a piecewise function. So you might be asking why this is important. Why do I need to do this? So the video that I made last night was on limits. And if I go ahead and try to solve a limit, let me just make one up really quick. So the limit is 2x plus 4. And someone's driving by my house on scooter right now, and it is absolutely raining. So let's say goes to -2, and then I'll write this guy over as x plus 2. And I'm going to say -2 from the left side. So that's what that little symbol means on the top there. It's like an exponent negative sign from the left side. So you have to decide what piece of the absolute value function I'm doing my limit for. So am I doing it for this guy or am I doing it for this guy? So that little symbol is going to tell you what you're going to use. So if I'm doing it for the left side, then I have to think about this graph. So the left side is literally the left side of this -2. So it's this entire thing right here. So it's that guy. So what I can change my actual limit to is -2 from the left side of -2x plus 4 all over x plus 2. So then I can go ahead and do my limit. So I can just go ahead and factor this guy. So I have a -2 on the outside, and then, well, I'm taking a 2 out, so I'm left with x plus 2 all over x plus 2. So I can cancel that, and then I have negative 2. There it is. Now the only tricky part when it comes to this stuff is that what happens if I have a negative slope? So let me just do this for another one where I have a negative slope. So let me just try, keep it simple, x plus 4. Y is equal to x plus 4. So let me just do a quick graph of this. So my x-intercept is 4 right here, and it looks like this. Alright, so if I go try and decide which piece, so really there's only two pieces that make up this thing. It's what's inside the absolute value function, and then it's the opposite of what's inside the absolute value function. Because remember, all absolute value is basically makes a negative number positive. So by taking the opposite, it just essentially makes that number positive. So the opposite of being, of course, if it's negative, it goes to positive. Alright, so if I look at this, this has a negative slope. So the unchanged version of this guy is now on the left side. So that's what makes this a little bit tricky when there's a negative slope. Whereas now if I take the opposite of this, it makes the numbers positive. So there it is, right? So there's the positive part, there's the negative part. But the tricky part is that this is just what's inside. So if I go ahead now and write this as a piecewise function, so I have negative x plus 4. The only tricky part is that this is less than or equal to 4. So the less than part comes first in these examples. So what that means for you, or what that means for you, I guess, is that you have to really be watching for the slope when you're doing a limit. So let me give you an example. If you have this, the limit as x approaches 0, let's not go 0. Let's go to negative 1 from the left side, and let's call this negative x, clearly, and negative x minus 1 all over x plus 1. So, and then I have the limit as x goes to negative 1 from the right side of negative x minus 1 all over x plus 1. So hopefully that works out. So we have to be very careful about what we choose for our limits. Sorry, not our limits, for when we get rid of the absolute value. So if I have a negative slope, then what that means is from the left side, I'm just going to basically get rid of the absolute value. And then I'm left with this. Whereas if I have a positive, the right side, I'm going to take the negative of it. Just like that. Alright, so that's important. So if I have a negative slope for a linear function, and I'm coming from the left side, I just get rid of the absolute value. Whereas if I have a positive, or if I have a negative slope, it's coming from the right side, then I have to take the negative of it. So let's contrast that with this scenario. It should be plus 1. And the limit, and that's the left side, limit as x goes to negative 1 from the right side, x plus 1. So if I sub in negative 1 from this side, it's indeterminate form. So again, I have to sort of do something with this absolute value. So if I look at this, this is from the left side, I have a positive slope, therefore I just take what's inside the absolute value. Or sorry, I make the negative, I mixed it up. And then this guy right here, I just take the absolute value because it's from the right side. So that's really important to recognize. You get rid of the absolute value here because you have the plus sign, and then you keep the up and you put the negative here because you have the minus sign. So it's kind of a tricky thing to think about, guys, but you really have to figure it out in your own head. I mean, I'm trying to explain what's going on here, and I think the graph does the best job of explaining it, because if you think about it, if you graph this linear function it would look like this. This line right here, negative x plus 4. So you can see this is the reflected part. So that's the part that gets the negative. The same thing with this guy. So if I graphed 2x plus 4, that right there, this is the reflected part. So that's what gets the negative. So the slope determines what the reflected part is, right? Like if I have a positive slope, the reflected part is on that side. So I get a negative. Whereas if I have a negative slope, the reflected part is on the right side now. So that's why I have to choose to put that negative in the right location. So let's just go back to this for a second. So if I have a negative slope, then my reflected part is on the right side. If I have a positive slope, then my reflected part is on the left side. So that's all you need to remember. Positive slope, reflected part, left side. Negative slope, reflected part, right side. Alright guys, I know it's a confusing thing to do, especially when you have a lot of limits and things like that to know, but absolute value limits are a common one that shows up on these things. I'm going to make a video with a bunch of examples coming up shortly. So I thank you for watching. I appreciate the effort that you're putting in, and keep working hard. Hard work pays off.